Hi everybody, this is Miss McClellan here to go over notes IM2 1.3.1 with you. What is the relationship? Today we have one learning goal and we'll write it in the first person. It is, I will be able to, when given a diagram, I will be able to identify and apply concepts of vertical, complementary, and supplementary angles to determine missing angle measures. And we'll get right to it. Now 168. Angle pair relationships. When working with diagrams in this class, we can assume that lines and segments that appear straight are straight. And we can rely on geometric markings. So for example, you can assume that this is a triangle, even though, in truth, I didn't draw perfectly straight lines. And you can rely, if I do these markings, that all the angles are congruent. And you can rely, if I do these markings, that all angles are the same length, that all sides have the same length. You can assume that figures lie in the same plane. That means that if I were to draw this square and this square, you can assume that they're meant to be represented on the same page. What you can't do is assume that, for example, this is also an equilateral triangle. Without the markings, I can't say that. I know it's a triangle, I know it has three sides, I know the sides are supposed to be straight, but unless I show you those markings that tell you the sides are the same length, you can't assume that, which is going to be important in today's lesson. Okay, here we go. Part A. Two angles whose measures have a sum of 90 degrees are called complementary. Here we have angle ABD. And we're told that it's a right angle by this symbol right here. And therefore, angles ABC and CBA must be complementary because they combine to make that 90-degree angle. Now, if the measure of angle CBD, and I'll make it blue, C to B to D, is 76 degrees, what is the measure of angle ABC? Well, let's make ABC green. And I'll call that measure X. And I know that 76 plus X equals 90. Okay, subtract 76 from both sides of this equation. And you end up with the final answer, X equals 14. Therefore, the measure of angle ABC is equal to 14 degrees. Great. Moving on. Part B says, if the sum of two measures is 180 degrees, it's called supplementary. In the diagram below, angle LMN, this is a straight line, LMN, is a straight angle. The pair of adjacent angles, LMP, which I'll do in pink, LMP and PMN, which I'll do in green, PMN, are called straight angle or linear pair. Now, if LMP is 62 degrees, what is PM angle, the measure of angle PMN? So I'll call that X. Now I know that combined, the two angles must equal 180 because they fall along a straight line when you put them together. So I have 62 degrees plus X equals 180. And I'll subtract 62 from both sides, which gets me X is equal to 118 degrees. Therefore, the measure of angle PMN is 118 degrees. Continuing. When two lines intersect, the angles that lie on opposite sides of the intersection point are called vertical angles. For example, in the diagram at right, angle AED and angle CEB, so AED and CEB are called vertical angles. Let's see if we can name another pair of vertical angles. So I can also see that I've got angle AEC, which is opposite DEB. Therefore, angles AEC and angle DEB are also vertical. Period. Okay. Moving on. Part D. Using the diagram, determine the measure of angle AEC, DEB, and CEB if X is 23 degrees. Okay, first I'll do, how about AEC? Okay, so I see that this is on a straight line. And I know that straight line angles add to 180 degrees. So I'm going to say that the measure of angle AEC plus 23 degrees is equal to 180 degrees. And then I'll just solve this by subtracting 23 degrees from both sides. My equation, which gets me that the measure of angle AEC is equal to 157 degrees. Next, I'll find the measure of angle CEB. So I know that the measure of angle CEB, this is another straight line pair, plus 157 is equal to 180 degrees. I subtract 157 degrees from both sides, and I get that the measure of angle CEB is 23 degrees. And it should be, because if 157 plus 23 is 180, I've basically already done this problem. And then lastly, I have this angle. I know that 23 plus 157 is 180. So I can skip the equation and write that the measure of angle DEB is also 157 degrees. You might be tempted to say, of course it is, because it's across from the other angle. And actually, that's where we're going. So if you're itching to do that, you're on the right track. Problem 1-70. A conjecture is a statement based on incomplete evidence, which is unproven. When angles have equal measure, they are called congruent angles. Jacob claims that all vertical angles are congruent. Do you think that Jacob's vertical angle conjecture is true? Look, it's true for the problem previous. I'm going to guess that it's always true, but we'll have to prove it. Jacob explains using a diagram with intersection lines. He wrote that here, A plus B is 180 degrees. That should be true. And A plus C should also be 180 degrees because those are supplementary angles. These statements have to be true. These statements are true. I know because supplementary angles always add to 180 degrees. Supplementary means on straight line angles or a straight line pair. We're going to use Jacob's statement in part B to prove that angles B and C are congruent. Okay, so I have that A plus B is 180. And I have A plus C is 180. I want to show that B equals C. To do so, I'll solve each of these equations for the variable that I desire. Here I desire B. So to get B alone, I subtract A from both sides and I get B is equal to 180 degrees minus A. Similarly, here I want to get C alone. And by the way, originally I was missing an equal sign. If you were missing a 2, please go ahead and add it in. It belongs right here. I want to get C alone, so I will again subtract A from both sides. And I get C is equal to 180 degrees minus A. Therefore, B and C are both equal 180 degrees minus A. Now this proves that all vertical angles are congruent, and that's because letters A, B, and C could take on arbitrary values. Thus, I have proven every case. Now I'm going to add something to this proof. The only thing that would make it really truly complete would be to say, let A, B, and C each be between 0 and 180 degrees. Because I really want to be talking about positive angles that add to 180 in this situation. All right, part D. Once a conjecture is proven to be true, it is referred to as a theorem. Since I have proven that vertical angles are always congruent in part C, I have now established the conjecture to be a theorem, which means we can use it in the future without proving it again. What's the difference between a conjecture and a theorem? Well, they might say the same thing. But a theorem is backed by proof, and a conjecture is something I may believe without proof, having proven it yet. Last problem, 1-72. For each of the diagrams below, identify an angle pair relationship and use the angle pair relationship to write and solve an equation. And then we're going to answer the question. So this really has three parts. We're going to first identify an angle pair relationship. I'll do that in blue. And I'll do that first. Here we have angle J and M and P are supplementary. They add to 180 degrees. Angle J and M plus angle M and P equal 180 degrees. They are supplementary. Okay, part B. What is the measure of angle FGH? Okay, well, just looking at this diagram, I see that I have these markings here, which tells me that the two angles have the same value. Therefore, angle FGH is congruent to angle KGF. Notice I used this symbol, which means congruent. Congruent refers to geometric figures. If I had used an equal sign, I would have been talking about the angle measures. Okay, part C. Right away, looking at this, I see that these angles are complementary, meaning they add to 180 degrees. Angle ABD plus angle DBC should equal 90 degrees. I hope that's what I said. They are complementary. And I know that because I have this little square in the angle telling me so. Okay, here I'm being asked to find angle NPM, and I think I might need two angle relationships for this. First, I see that angle LPQ plus angle QPM should equal 180 degrees. They are supplementary. It's a straight line. Next, I notice that angle LPQ should be congruent to angle NPM because they are vertical. So now I've named all of my angle conditions. Pick another color, and let's do this next part. We're going to use the angle pair relationship to write and solve an equation. That's part 2. Here I have 7x plus 3x equals 180. That's 10x equals 180. Divide both sides by 10. And I have x equals 18 degrees. Here I have congruent angles, so I have 4x minus 5 equals 3x plus 2. I subtract 3x from both sides, and I add 5 to both sides. That gets me x on the left is equal to 7 on the right. Next, I have complementary angles, so these two angles will add to 90 degrees. That's 2x minus 4 plus x plus 7 equals 90 degrees. Combine like terms, getting 3x plus 3 is equal to 90 degrees. I want to divide everything by 3. I think that'll make it easier for me. I have x plus 1 is equal to 30 degrees, and x, subtract 1 from both sides, getting me x is 29 degrees. Okay, this I think will take a couple more steps. So first I'll use the supplementary relationship. I have x plus 28 degrees plus x equals 180. Combining like terms, I have 2x plus 28 equals 180. I divide everything by 2, getting me x plus 14 equals 180. Subtract 14 from both sides. And I have x is equal to, oh, I'm sorry, I made a mistake. I should have had x plus 14 is equal to 90, which means x is equal to 76 degrees. All right. I guess that wasn't 2 steps. Let's continue. Part 3 will be answer the question. Okay, so I'm asking what is angle MNP? Angle MNP is equal to 3x, so angle MNP is equal to 3 times 18, which is 54 degrees. That's the final answer for angle MNP. Okay, and now what's the measure of angle FGH? So the measure of angle FGH is equal to 3x plus 2. That's 3 times 7 plus 2, which is 21 plus 2. So the measure of angle FGH comes in at 23 degrees. Okay, next, what is the measure of angle DBC? Angle DBC is equal to x plus 7. So that's going to be 29 plus 7. Therefore, the measure of angle DBC comes in at 36 degrees. Last but not least, I'm asked for the measure of angle NPM. The measure of angle NPM is equal to the measure of angle LPQ because they're vertical. Therefore, it's equal to x plus 28, which is 76 plus 28, which is 104. So the measure of angle NPM comes in at 104 degrees. Done. Yes. Students, I hope you have a beautiful day. I'll see you next time. Bye.